We know that the Earth is ever-changing and evolving. Each day as technology grows more advanced, we uncover more things in the universe and learn more amazing things about the planet. Sometimes the discoveries are fascinating, but other times we learn some things that alarm scientists. Have you ever wondered if the planet could explode? Decades ago, no one would think that this was possible, but the Earth has been busy, and despite the environmental changes that humans contribute to, scientists now warn that it's very possible that a huge global catastrophe is currently in the making. Conditions on the planet continue to change drastically with the current global warming trend. Places where water was plentiful have dried up, causing global droughts. Massive amount of Arctic ice is melting, and more than half of the Earth's largest aquifers are being depleted at alarming rates. 21 out of 37 of these freshwater aquifers that supply 35% of fresh water to humans are losing more water than is being replaced, and these aquifers can take thousands of years to fill up, which slowly recharge from snowmelt and rains. But humans aren't the only ones consuming water. The Earth is sucking tons of water into its interior, and scientists have no idea where it's going. Many of you might not know that the planet itself is drinking up its own oceans, but scientists have known this for years. However, a new startling discovery made by researchers has shown that the Earth is devouring 3 times as much water as once previously thought, through what are called subduction zones. These boundaries mark the collision between 2 of the planet's tectonic plates, which are gigantic pieces of Earth's crust that slowly move across the surface of the planet over a period of millions of years. Where these 2 tectonic plates meet at this subduction zone, one plate bends and slides underneath the other, which then curves down into the hotter layer under the crust called the mantle. One of these places where 2 oceanic plates meet is the Mariana Trench in the western Pacific Ocean. Deep down under the surface, the area is an otherworldly environment full of alien-looking creatures, and it is considered to be the deepest part of the Earth's surface. It appears from satellite images as a crescent-shaped scar that stretches 1,584 miles long and is 42 miles wide. Its deepest point is opposite of the cruising altitude of a passenger jet at 36,000 feet below the surface. The deep holes in the trench were formed due to the collision of the converging Mariana Plate and the huge Pacific Plate. It is the motion of these plates that are dragging down the water many miles below the surface, which is estimated to be deeper than 60 miles. Researchers were able to discover this by listening to a year's worth of sounds that the Earth makes, from ambient noise to actual earthquakes. A network of 19 passive ocean bottom seismographs was placed across the Mariana Trench, and 7 island-based seismographs were also used. The speed at which the seismic waves travel indicate how much water the rocks could hold. The seismic images obtained show that the area of hydrated rock at the Mariana Trench extends almost 20 miles beneath the seafloor, much further than previously known. Previous conventions were based on active source studies, which can only show the top 3 or 4 miles into the incoming plate. And for those who are curious, yes, rock can hold water. The key to storing the water is a mineral called ringwoodite, which is a form of olivine that exists under high pressure and temperature and acts like a sponge that attracts hydrogen and traps water. This mineral can contain a lot of water under conditions of the deep mantle. Earth's mantle is so vast that if 1% of the material in the transition zone is actually water, it would represent a reservoir 3 times larger than all of the Earth's oceans combined. Water being pulled into these subduction zones plays a big part in other things happening around the planet. When water runs down into the Earth's crust along these subversion zones or fault lines, some of it becomes trapped, and at certain temperatures and pressures, chemical reactions create what is known as wet rocks, which is a hydrous mineral that forms part of the tectonic plate, and that gets pushed deeper and deeper into the hot mantle. Researchers also found that the amount of water held in rocks was far higher, up to 4 times the previous estimates. If applying these findings to subduction zones around the world, this tells us the amount of water being pulled into the Earth's interior through subduction zones. The amount of water that these zones swallow is equal to 3 billion teragrams every million years. So where is all that water going? It would seem that what goes inside the Earth must come back out somewhere. sea levels have remained relatively stable over geological time. This means that all of the water that is going down into the Earth at subduction zones must be coming back up somehow and not continuously piling up inside the Earth. It could be possible that there might be vast underground oceans or lakes that we are unable to see. It's well known that water inside fault lines and between layers of rock act like lubrication. When tectonic plates are holding a lot of water, they are more easily able to slide under each other. The movement of tectonic plates creates earthquakes, and the more they move, the more powerful the Earth's tremors become. It is very possible that the continents could start to move much more than normal and change drastically over the next 1,000 years. Earthquakes are very common. In fact, there are about 20,000 earthquakes each year. That's 55 earthquakes worldwide every day, with around 15 of those being in the magnitude 7 range. Scientists have warned that there could be an increase in earthquakes due to the Earth's slowed rotation. The link between the Earth's rotation and seismic activity is strong and suggests that there is going to be an increase in numbers of intense quakes. If the Earth is pulling in more water in the subduction zones, the slower rotation combined with this could cause worldwide chaos. Earthquakes and volcanic activity go hand in hand, and both produce tsunamis, which are incredibly swift and dangerous. We know that the amount of water ingested by the Earth and the amount emitted isn't equal. In fact, the amount going into the Earth wildly exceeds the amount coming out. The great mystery is that there must be something about the way the water moves inside the Earth that we don't understand. It could very well be possible that most of the water is being emitted back into the atmosphere as water vapor in volcanic eruptions. Today, we are seeing a lot of volcanic activity that could be directly related to the water going into the planet. In a low-temperature process, which is called serpentinization, water infiltrating the mantle through faults hydrates the mantle rock on both sides of the fault. The mantle rock is transformed into serpentinite, a rock with a dark scaly surface like a serpent's skin. As this slab plunges deeper into the hot mantle, dehydration reactions release water, which at such incredible pressure and temperatures become a supercritical fluid that can drift through materials like gas vapor. This fluid rises into the overlying mantle and lowers the melting point of rock and can trigger violent eruptions of magma. It is this same violent eruption of magma that created the Mariana Islands. But the eruptions caused by this process don't just happen close to Mariana. They can happen hundreds or even thousands of miles away. In October of 2018, 18 U.S. volcanoes were classified as a very high threat because of what is happening inside them. That danger list was topped by Hawaii's Kilauea, which coincidentally has been erupting this year. Among the others that seem to be on the verge of an eruption are Alaska's Redoubt, Mount Okmok, Akutan Island, and Mount Spur. Wyoming's Yellowstone volcano has been active, and there have been small swarms of earthquakes felt in the area over the last year. Yellowstone is a supervolcano that is essentially a giant, lid-topped cauldron. It's so vast that the entire thing can only be seen from low Earth orbit. Its crater expands out 45 miles across, and just underneath the surface lies tens of thousands of cubic miles of magma. This magma could very well be increasing due to the fact of the massive amount of water going into the planet. One of the more surprising and devastating volcanic eruptions during 2018 was Krakatoa, or Anak Krakatau, in Indonesia when it erupted recently on December 20th. Its volcanic cone, which stood 1,115 feet high, now only stands 360 feet. And the eruption caused part of the island in the Sunda Strait to collapse into the sea, which triggered tsunami waves of more than 7 feet high, which devastated parts of the island. It could very well be possible that we will see increased volcanic activity due to the intake of the Earth's water, and along with this, possible global catastrophes of which we have no control over. What do scientists think? The Earth has been around for 4.5 billion years. The land masses we see on the globe currently formed as the planet's plate shifted and collided over millions of years. Those same changes that broke apart the continents will continue. Tracing the water cycle within subduction zones will allow scientists to better understand volcanic activity and subduction zone earthquakes, the most powerful earthquakes in the world. The phenomenon has major implications for the global water cycle. The stark reality of the findings is that because of the big inconsistency in how much water is being absorbed and how much the planet is expelling, means that in time, the amount of water inside the Earth will continue to increase, and the water on the surface would decrease, and our planet could end up looking a lot like Mars. What can we do? As helpless as we might seem, we are learning more about the planet and what stages it goes through. We know from geological studies that the Earth has seen some incredible disasters, from ice ages, supervolcanic eruptions, and asteroid impacts. On the grander scale of things, we can only learn how to better detect when something is going to happen with advanced technology. But in the end, it's not possible to stop Mother Nature. Earth will continue to change as it always has, with or without us. We're just along for the ride. We hope you enjoyed the video. Do you have any good ideas for our next video? Share them with us in the comments. And if you liked the video, don't forget to subscribe and turn on notifications so you will be the first to know when we release a new video. Thank you for watching, and we'll see you next time.